Hello, my name is John Ignosh. I'm an extension specialist with the Department of Biological Systems Engineering at Virginia Tech. This poster is presented with lead author Ingeniero Mario Buch from Guatemala. Our poster is titled Exploring Agrophotovoltaics in Guatemala to Foster Positive Change. For a little bit of background context, I want to talk a little bit about the situation in parts of Guatemala. In recent years, news headlines have focused on unaccompanied children coming to the U.S. border from Central America, with many originating from Guatemala. Many of the unaccompanied children are around 15 years old. There's many drivers causing this outmigration of teenagers, including citizen security issues, food insecurity, climate change, lack of economic opportunity, among others. Very complex issue. Yet potential economic opportunities in ag value chains exist to generate more employment opportunities in the formal sector. Increasing exports of non-traditional ag products could help generate additional employment, and diversifying production to high-value products could increase farm revenues sixfold. However, with these more complex production systems require enhancing technical assistance capacity. Ag tech training institutions offer a strategic avenue to help capitalize on these opportunities and affect these broader changes. The National Agricultural and Forestry Education System in Guatemala is led by the ENCA. In English, ENCA stands for the National Central School of Agriculture. The map to the right shows the network of 19 schools across the country. The location in red indicates the headquarters school, ENCA. This network of 19 schools educates approximately 4,000 agriculture and forestry students each year, graduating about 1,300 technicians annually. Since 2018, a project team consisting of the headquarters school, the broader network, GOPA consultants from Germany, Earth University in Costa Rica, and Virginia Tech have collaborated on a program sponsored by the Millennium Challenge Corporation focused on enhancing educational curricula, private sector engagement, and teacher training opportunities across this network in Guatemala. This project work also served to build opportunities to explore additional collaboration opportunities. For example, ENCA and Virginia Tech are collaborating to explore opportunities to integrate innovative renewable energy technologies with ag production systems to foster experiential learning opportunities for students across the network of 19 schools. Most of the students in these schools are 14 to 18 years of age. Adoption of technical, pedagogical best practices will help the nation reach its potential and bolster goals to spur greater economic activity in the ag and forestry sectors, thereby affording greater economic opportunities and futures for the youth involved. Now, what are agrophotovoltaic systems, or APV for short? The Fraunhofer Institute for Solar Energy Systems in Germany defines APV as ag production underneath ground-mounted PV power plants that are specially developed for this purpose and a resource-efficient dual use of arable land to mitigate conflict between food and energy security. Figure 2 to the right is a graphic for a conceptual APV system from the U.S. Department of Energy's INSPIRE project. Now, why APV in Guatemala? Why is that of interest to us? Well, Guatemala is the second most densely populated in the country in Central America, as indicated in Figure 3. To enhance ag productivity with a limited land area, the country has adopted many agroforestry systems to develop multi-canopy structures to enhance growth of cultivation systems such as cacao, coffee, cardamom, among many others. These forms of production systems can yield multiple benefits and enhance sustainable land use intensity and system resiliency. Conceptually, APV systems are very similar and may serve as an opportunity to produce multi-benefit production systems for certain locations to complement certain forms of ag production. Now, it's very early in our collaboration with ENCA to explore potential APV use cases, but some of the ones that have initially caught our interest are highlighted here in figures 4, 5, and 6. Figure 4 highlights an area of the country called the Dry Corridor, where pronounced droughts have resulted in many socioeconomic challenges. In this area, there are two ag tech schools about 22 kilometers apart, road corridor connecting them with two electrical transmission lines running along and parallel to that road. If a 10 kW APV system were to be installed in that area, it's estimated to generate approximately 16 megawatt hours of electricity, with approximate energy value of $3,000 US. The impervious surface of that size of array uh, could collect approximately 10,000 gallons of water per year, potentially to use for crop irrigation during strategic intervals of the growing season. Figure 5 looks at some of the rural electrification areas in Guatemala, again, in areas with ag tech schools. The municipalities in light yellow have less than 33% electrification. Uh, for smallholder farmers in those areas on limited parcels, lacking grid-tied electricity, perhaps an APV system could be something to be explored for those applications. Figure 6 looks at the many production systems in the region which use some type of shade, agroforestry controlled environment ag, shade houses, with systems with knitted polyethylene shade cloth. Now perhaps an APV system in these production systems could also be a means to generate additional co-benefits while also providing the needed shade. Now, the response so far and potential impact, if we're able to continue and move forward with an actual APV project demonstration. Now, the school's motto, ENCA's school's motto is Aprender Haciendo, learn by doing. So in true fashion, students have been involved. For example, ENCA students have managed solar-powered irrigation systems using a future pump, figure 7 there in the bottom left, for irrigation applications during the dry season. Similarly, Virginia Tech senior design teams have visited ENCA for different project evaluations, including an APV project. That's figure 8, project poster from the design team, and then also some site analysis work in the lower right corner there. While these project opportunities are in their early exploratory phases, system concepts show promising opportunities for applications on school campuses and beyond. If successful, future campus-linked APV project demonstrations will enable hands-on learning opportunities to foster skill set development, to spur broader development opportunities in the sector, and foster positive change for the youth, by the youth, and the region. Thank you very much for your attention.